We were working for a high-growth fintech startup. Everything was scaling perfectly. Our user base was doubling every month, our latency was down, and the team was riding the high of a successful Series B. We were the golden children of the engineering world. Until the first email arrived, a user claimed their account balance was off by exactly 3 cents. We checked the transaction logs, every credit and debit matched. We chalked it up to a misunderstanding of how interest was calculated and moved on. But then, a week later, another email arrived, then 5, then 50. The strange part, it wasn't always 3 cents. Sometimes it was $1. Sometimes it was 10. And yet, when we ran our internal audits, the math always balanced. According to our database, the money was exactly where it was supposed to be. We were in a state of total confusion. We had built a technically perfect system. Our unit tests had 98% coverage. Our integration tests were green. We were performing engineering at the highest level. But in the real world, our users were seeing ghosts in their bank accounts. The suspense in the office was suffocating. We spent 48 hours straight in the war room. We reread every line of the ledger logic. We audited the third-party payment gateways. We even suspected a sophisticated external hack. It wasn't until we looked at the serialization layer, the part of the code that translates the raw data from the database into the JSON that the mobile app displays, that we found the ghost. Hidden in a shared configuration file was a single line. Rounding mode, round half even. In most cases, this is a standard way to handle decimals. But in a specific edge case involving multi-currency conversions and high-frequency microtransactions, this rounding mode was creating a floating point discrepancy. The database was stored in integer sense, but the display layer was converting them back to decimals using a library that had been configured incorrectly for financial data. The system wasn't broken in a way a compiler could catch. It was perfectly executing a flawed instruction. It was cleanly and efficiently lying to our users. In that moment, we weren't product engineers, we were just mathematicians who forgot that math has consequences. A coder looks at a green test suite and goes home. They trust the tools. They trust the clean code. But a product engineer knows that tools can be misconfigured. They understand that correct code can still result in a wrong product. They look past the syntax and into the data flow, asking, where could the truth get lost in translation? This brings us to the clarity moment. The human impact of the silent corruption wasn't the loss of a few cents. It was the total collapse of integrity. It took us 6 months to rebuild the trust we lost in 48 hours. Users don't care if your code is elegant or if you use the latest framework. They care if they can trust you with their lives, or in this case, their livelihood. Professional maturity is realizing that your job isn't just to ship features, it's to be the guardian of the system's truth. Clarity is understanding that the most perfect code in the world is garbage if it produces an untruthful result. So here's my question. Is there a rounding error in your logic? Not a bug that crashes the app, but a subtle lie that's slowly eroding your users' trust. Don't wait for the emails to start coming in. Find the truth now. Let's get clear. See you in the next one.